Hey guys, in this micro lesson, I wanted to talk about a phenomena we deal with every day, whether that's, say you're stirring your tea in the morning, and you notice that the spoon sort of uh, breaks at the surface, and you stick it in at a certain angle, but it goes into the tea at a different angle. And what's going on there? You can do this right now with a cup of water and a pencil, although I'll save you the time, and I've gotten it drawn right here. And why is it that it looks like this? Well, to understand this, we need a basic knowledge of trigonometry, that uh, what the function sine is. And you also need to understand what photons are. So that light travels in these particles called photons, and these clumps of photons make up rays of light. And to explain this phenomena, we're going to use something called Fermat's principle. And Fermat's principle basically states straight up that light wants to travel from point A to point B as quickly as possible. Now, you might say, okay, well, in that case, it should always be a straight line. A straight line is always the fastest from point A to point B. And I say, hold on, um, that's not true. Uh, in different mediums, so in different material, say water versus air, light's going to take longer to travel through the water than the air. And this is because the water is denser and there's more particles in the way, and that the uh, particles of light, the photons, are going to have to collide with these particles, whereas in the air, it might be less dense. Less dense. There we go. Uh, and in this case, the light will travel less long in the water and longer in the air. And you can sort of think of this as a runner that has to run across different terrain, where you want to get from point A here to point B. However, let's do it like this. However, this is normal pavement, and this is mud. Well, in that case, it might not be fastest to go all the way over here and straight down. That might be too long of a path. And going straight means you travel too long through the mud. But coming down here and then going straight over to the mud and sort of creating these two different angles might be fastest. Uh, and in fact, that's what we see with light, and that's true with light. Light obeys what we call Snell's law, and Snell's law states that the ratio of the speed over the sine of these angles that are created with what we call the normal, which is just a perpendicular line to the surface, are equal. And we can sort of rearrange this using the index of refraction. And index of refraction is a fancy term stating that's creating some n that is equal to c over v, where c is the speed of light in a vacuum. This is the speed of light we're all familiar with when we learn about light that travels as a wave. And this is the speed the light travels through that medium, through medium. And if with these factors, we can rearrange the equation, and with a little algebra, come to the equation n1 sine theta 1 equals n2 sine theta 2. Okay, great. Now let's try and apply it, and let's do some case studies. So I've drawn out a few scenarios here, and I want to pause the video at this point and tell me which material is optically denser. So which has the larger N, or which one does the light travel slowest through. I'll go ahead and pause the video. Okay, time is up. Well, as we can see in the first scenario, the light bends further away from this normal line on material 2, so 2 is denser. And in this case here, well, the light is just going straight through. So this is the same material in the first in 3 and in this last case here, well, we actually have what's called the case of a critical angle here. Uh, and the critical angle occurs when the light sort of comes in and just rides along the surface. And you can use Snell's law to solve for this. In fact, I would encourage you to create an equation for the critical angle using Snell's law. Um, but essentially, this only ever occurs when this medium 5 is denser than medium 6. So if that was your guess, or if that's your deduction, then congratulations. Material 5 is denser than material 6. And that about sums up our video for today. Thank you for watching, guys. I encourage you to try out this to create an equation with the critical angle here to find it using Snell's law. And have a great day.